want to first do a lecture now,
Okay.
then later at the end, you guys if you have any questions, please have them ready for me at the end, okay?
Okay, sure.
All right, so we're going to talk today. We're going to continue with the radicals. So last time, the previous lecture was about introducing the radicals and simplifying them. There was also a general introduction to them. Today we'll see how to add, subtract, and multiply radicals. So we're going to pick up from where we left off in our previous lecture, homework 15, and assuming you did the homework for that and you did the lecture, so that's necessary for understanding what's going on, what we're going to learn today. So let's start with addition and subtraction of radicals. And later we'll do multiplication, probably division as well if you have some time. So addition and subtraction. So there's one rule to remember when you add radicals. For example, radical 5. You want to add that to maybe another radical. Let's say 3 here and maybe 7. So the first thing you want to do when you add or subtract radicals is to check the index. Again, the number that's here is the index. What is the index of this radical, by the way? The first one?
3.
No, that's not the radical. This is 3 times this radical. So this radical doesn't show an index.
2.
That's right. That means this is radical index 2. Also here, index 2. So when you add or subtract radicals, first you want to check these two. They have to be the same. And also the inside or the radicand must be the same. If those are the same, then you just add the leading numbers. You say 3 plus 7. And here you have radical 5, index 2. So basically just add the leading coefficients here. That's 10. Then you have radical 5, index 2. So that's important when you add radicals. So when you add radicals, you must have the same radicand and the same index as well. Okay, same thing with subtraction. Let's say you have 11 minus radical, let's say 4, index 3 minus 6, radical 4, index 3. Okay, so again, can we subtract these right away?
Yes.
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 And
Okay.
11 take away 6.
That's right, we have 3 and 3, that's good. We have 4 and 4. It must be the exact same radicals. And we just add or subtract the leading number. This is 11 times this. Just like saying 11x minus 6 of the same thing, x. Okay, 11x or 11 radical 4 minus. We can subtract these by doing the subtraction. We say 11 or 11 minus 6 is 5x. Same thing with the radical. So when you have 11 and a radical, that means 11 times that radical, just like 11 times x. So this will be 11 minus 6, which is 5. And the index and the radicands don't change. So we have 3 and we have 4 here. So that's very important. Whenever you add or subtract, you need to look at the index and the radicand. Now let's look at another example. Let's say say we have radical so 9 plus 3 and maybe radical 8. Actually, let me make it. So here we have another example of adding 2 radicals. What is the index of this radical again, by the way?
2.
2. So invisible radical means index 2. So now we have index 2. Can we add these two radicals right away?
No.
Can we add these two radicals right away? And
No.
No.
that's right now, because we have different indexes, also different radicals. So if you can't add right away, if we can't add these right away, then we're going to try to maybe simplify this, and possibly be able to add them at the end. This, we know what is the value of this. This is radical 9, index 2, or the square root of 9. That's basically, what is that equal to? This radical, what is it equal to? This is
1/2.
No, this is just radical 9, index 2. In other words, the square root of 9. What is the square root of 9?
3.
3.
That's right.
3.
3 plus. Then we go over, we have 2 times. We have 2 times, what is the radical of 8, index 3, or the cube of 8?
2.
That's right, as we saw in the previous lecture, this is 2. Now we can continue simplifying, so we can say we have 3 plus 4, which is 7. Okay, so if you can't add right away, try to simplify each one by itself and then add them. If not, sometimes you just can't add. Let's say you have, say 3 radical 7 minus 2 radical.
Sorry, Professor.
Yes?
Sorry, I was absent last Thursday, so actually I don't understand this part. 3
Okay, I posted,
plus 1.2.
I posted the lecture for last class, I posted it.
I watched it and I read it already, but I still don't understand.
Which
you
part do you understand exactly?
3 plus 2.2 and 3 plus 4.
Yeah, this is radical 9, right?
Yes.
3. We have 2 here times this. We have the cube of 8. The cube of 8. What
Yes.
number multiplies by itself 3 times to get 8?
2.
Times that number is 2. That's why I have 2 here. Okay. Then I multiply these two. 2 times 2 is 4. And add these 2 into 7. Okay, so that's where the 2 come from.
When we multiply 2, we get 6, right? But we still leave 2.
When you multiply 2 by itself 3 times, you get 8. 2 times 2 times 2 is?
Oh, okay, sorry, I got it.
Okay.
Yep.
All right, so now there's another example. So again, we have radical 7, so the index is 2 here, invisible, minus 2 radical 3, 5. Can you subtract these two right away?
No.
Can, right? Also, we can't simplify them. Radical square root of 7 is a decimal. It's not a whole number, so no need to turn it into a decimal. You will need a calculator for that. And here, same thing. A number that multiplies to itself 3 times to get 5, that number is a decimal. We would need a calculator. So we can't simplify it unlike these. They were simplified. So this basically does not, it stays the same. Okay? It does not subtract unless you want to turn it into decimals, and you'll get some decimal from this with a calculator. But with radicals, we try to keep them in the form of radical if possible, but also reduce them as much as possible. So that's an example of something you can't add or subtract. Also, if you have radical 3, radical, let's say 8 plus maybe, that's another example. These are different, so the index is different, the radical is different, okay? Can't add unless you add the decimals. Okay, so that's another example. So make sure when you add or subtract, you must have again, the same number inside, same index outside, then add. If not, you can simplify first. Can you guys hear me okay? Do you hear me well?
Yes, but I have another question.
Yes.
What is it?
When the index are different, can we make them to be same? For example, like index A, we make it to be like
You can't change the index. The index can't be changed. Maybe we can simplify inside, but not the index. The index does not change. Here's an example. So let's say you have maybe radical 2 here. Maybe radical, let's say, okay, let's say radical 2 plus maybe radical 8. Let's add a number here, maybe 3. First of all, can we add these two right away?
No.
We can. So because even though the index is the same, the index is 2 here and 2, but the inside is not the same, so we can't add right away. So always, if you can't add right away, always try to simplify both radicals first and see maybe you can end up with something like this with the same number here, same index. We can't simplify this much, 3 radical 2, because we can't break 2 down, it stays the same. The index again is invisible, 2 plus. Over here, the radical of 8 again is a decimal, unlike radical 9, which is 3. This one is decimal, so we don't want to write it as a decimal. But we can break the 8 into what?
2 multiply 4.
That's right, we can break this 8 here into 4. So we're going to split this radical into 2 radicals. 4 times 2 is 8, so we can split that into 2 radicals. Again, we explained this in detail in the previous lecture. So now we can say 3 radical 2 plus radical 2. What is the square root of 2? I mean, radical 4.
2.
2.
Turns into 2. And this stays inside because you can't simplify. Finally, now as you can see, it's like this. So we have the same index, same radical, which is 2. The index also is here, is invisible. Okay, so the invisible index here means it's 2. Now what is this equal to?
5.
5 radical 2.
Yeah.
Exactly. 3 plus 2 is 5 radical 2. So the index stays the same.
Okay.
Also the radicand stays the same. So that's your final answer.
Okay, but can we take out the radical? I mean, to make everything it's same.
Yes, if possible. Yes, if possible, simplify, break them down first. Sometimes it's not possible, like here, so that stays the same. You don't do much to it. But if the radicands and the index are all the same, you can simplify. Let's look at another example here. Let's say I want to simplify this radical. Radical maybe 2 and index 3 minus okay, so we have 2 radicals here. I want to subtract them. First thing we can notice is we have the same index, which is good, but we don't have the same radicand, so we can't subtract right away. Maybe after we simplify these, we're going to try to get them to have the same number inside the radicand. Obviously here we can't break this down. 2 is just 2 times 1, so we can't break it down. So this basically is already as simple as possible. So we're going to write it down here. Subtract. Now we have 4 times radical index 3 of 16. This number, a number that multiplies to itself 3 times to give 16, is not exactly a whole number. So we're going to have to break this one down. Again, think about the index. It's not 2 here, so this is not 4. It's not the square root of 16, which is 4. This is the cube of 16. So since the number that multiplies by itself 3 times to get 16 is not a whole number, we're going to try to break this down into two numbers. One of those numbers should have a perfect cube. So what numbers do we use for 16 here, if you want to break it down?
8 and
2
2.
and 8.
Exactly, because we know that the cube of 8 is 2. So here we're going to break this down into 8 and 2, because 8 will turn into 2. So we're going to say 4. So radical 8 cube, and also 2. The index stays the same. We just split this into 8 and 2. So this is radical 3 minus 4 times, again, what is the cube of 8? Or the number that multiplies to itself 3 times to get 8?
2.
That's right, the number is 2. And this one, again, stays the same. You can't break it down, so we're just going to put it here, index 3. Simplify a little more. So that's 4 times 2. Whenever you simplify something, this is a multiplication. It's always multiplications here. I'm going to do 4 times 2, not plus. That's 6. I mean 8. And radical 2. Okay, what about now? Can we subtract?
Yes.
As you can see, we end up with same index,
Well,
same.
-1.
That's right, which is good. So just have to simplify this. 7 take away 8 is -1. And again, the radical stays the same.
so as long as the index and radical are same, they can add and subtract, right?
For additional subtraction, yes, we must have those. If we don't, again, we try to simplify first. If not, sometimes we can't simplify, we can't subtract. It stays like that. Unless you're looking for a specific value for a decimal, then you can use a calculator to find the decimal form of this. So that's pretty much how you do addition and subtraction of radicals. Now we're going to look at multiplication. So always break down your radicals. Sometimes you may have more than one. Let's actually do another example. You may have, let's say, so you may have more than just one radical. For example, here we have 3 of them, addition and subtraction together. So again, always check the index. If it's the same, check for the radicals if they're the same. If not, you can't add and subtract radical. What is the index again of these radicals?
2.
2.
That's right, it's an invisible 2 here. This is not the index. Index is small here in this corner. So what do you think we can do now to add and subtract since we don't have the same radical and the same index?
Find the common denominator, or find the common radical.
We're going to try to turn this into something with a common radical. That's right, kind of like what we did here and here. Always try to break down the radicals inside as much as possible. Simplify them. So this can't simplify. Because 5 is just 5. 5 actually. The other one, can we simplify the next one? The radical 50. We don't have the square root of 50. We know the square root of 49, but not 50. So it doesn't have a perfect radical, perfect root with a whole number. So what do you think we do to simplify this radical 50?
5 and 10.
Okay, if you use 5 and 10, this doesn't have a perfect square. This also.
Oh, 2 and 25. Sorry, 2 and 25.
Okay, 2 and 25 is better, so we're going to say 5. 2 and 25. Because 25 has a perfect root, which is 5. Okay, so this turns into 25 times 2 plus 2, and we have 45. Well, again, we don't know the square root of 45, it's a decimal, but can we break it down into something?
Yeah, 9 and 5.
Exactly, 9 and 5, because 9 times 5 is 45. Back to the first one, stays the same for now, minus square root of 25 is 5, radical 2 plus, this is 2, radical 9 is 3, so 2 times 3, that's 6, radical 5. Okay, so we simplified this as much as possible. Let's see what we can add next. What do you think adds up after this?
You do 3 minus 5 plus 6.
That's right, these two are similar radicals. As you can see, you have 5, you have index 2, so we can combine those two. Just like combining x, and you have y here. So like x, 3x, 6x, maybe negative 5y here. So I'm going to add these two, so 3 plus 6, it's 9, radical 5. This one is different because it does not have the same radical. We're just going to write it down here. And can we subtract these two?
No,
Okay, why not?
because the radicals, we have a 5 and a 2. It's not the same.
Exactly. The radicals are different. We have 5, we have 2, even though we have the same index, negative 2, negative 2. So there's not much you can do here. That's it. That's your final answer. Again, unless you're looking for a specific answer, decimal, you can use a calculator for that. But for now, that's pretty much it. So that's basically the whole idea of adding and subtracting radicals. It's pretty simple. Make sure you have the same index and radicand. If not, try to simplify them. If you can't simplify them, then you can't do much. It stays like that. So now let's look at multiplication of radicals. So multiplication is a little different. So as you saw here, we could split the radicals as we did here earlier. Radical 8, for example, we turn it into radical 4 times 8. So this, we turned it into that. That means we can just multiply the insides. Even though they're not the same, we can multiply them. So when you multiply radicals, only the index has to be the same, not the inside, not the radicand. So the index is the same, just times the values inside the radicands. And basically you get your 8. Okay, so the index again is invisible here, is 2. Okay, so no need again for the radicand to be the same. You can multiply any two radicals, let's say 5 and radical maybe 3. So whatever index, let's say 7 and 7. What is this equal to?
15.
Right, and the
Radical 15.
radicand stays the same, okay? It's 17. But again, this exists, it's a decimal point. Let's say radical 2 times radical 8. What is this equal to?
16.
Radical 16.
Right, which is?
4.
That's right, it's 4. So by default, again, this is square root. If it's 2, if it's invisible, that means it's 2 or square root of 16. What about this? Let's say you have maybe 2 here. Say 5 times . Okay, can you multiply these radicals?
Can we take out, can we change the radical to the fraction so we can multiply, right?
Even if you change it to a fraction, still may not help. unless you turn both into decimals and multiply. But right away, you look at the index, because the index is not the same, so you can't multiply these. So this basically just stays like that. You try to simplify both if possible. A number that multiplies 5 times to 2 or 3 times to 7. If you can find those, then multiply them. But this one can't multiply. Again, the index is different, can't multiply.
Professor, I have a question.
Mhm.
I read the books which from last Thursday, the page. In the book, they teach me a way to do this, but I'm not sure whether it's
That's
a
when you turn
correct way or not.
subtraction, right?
Yes, to become like 2 to the 1/5.
2 1/5 and 7
Yes.
1/3.
Yes.
But you still
Then
multiply. You must have the same base to multiply that. Okay.
oh, so the radical must be same, right?
In this case, yeah, just like adding times in x and x.
Mm-hmm.
X times a, x times power b.
Okay.
X plus b. But we're gonna get to that a little later. I didn't want to confuse you with that for now. So it may work only if you have the same radical here.
Oh, okay.
Okay, so that's this one can't simplify. Let's look at another example. Maybe let's say 27 here, and the index. We want to times that by some other number. Maybe 25 index 2. So you can't multiply these right away because the index is different. We have 3, we have 2 here. But it doesn't mean we can't multiply at all. We're gonna try to simplify this and see if we can get an answer to this. So what is the radical, or what is the radical of 27 index 3, or the cube of 27? What is the cube of 27?
9 and 3 for 27.
That's right. So a number that multiplies itself 3 times to 27 is 3 times, and of course square root of 25 is 5, and there you have it, 15. That's pretty simple. Unlike this one, it's a little inconvenient because these are not whole numbers, these are decimals. So again, just try to multiply right away. If not, simplify. If it's not possible to simplify, that's okay. Make sure you have the same index before multiplying radicals. You don't have to have the same number here. Just multiply the two if these are the same. Another thing is when you have two, let's say, so you have radical maybe 2, 3 plus maybe radical 8. So this is a multiplication. We have radical 2 times 2 numbers inside. So basically, we're just going to distribute this. So radical 2 times 3. As you can see, this one has a radical. This one does not have a radical. So it's not 6, okay? This times this is not 6. Be careful with that because this one does not have a radical. The other one, they both have radicals. So radical 2 times radical 8. So again, when you multiply radicals, you want to check the index. As you can see, these two do not have the same index because they're not both radical. This one is a radical, index 2, but this one is not. So basically, you just say radical 3 radical 2. Just say 3 radical 2. Think of it as x times 3, for example. So when you say x times 3, just say 3x. Same thing here. When you have a radical times a number, just bring that number to the front. So this is 3 times radical 2. Again, do not make the mistake of making it 6. It's not 2 times 3. It's not 6 because this one does not have a radical. But with these two, they both have radicals, same index, we can multiply these. We can say radical 16. Be careful when you distribute something like this. So this will turn into radical 2 plus the radical of 16 is 4. Can we add these two? Can we add 3 and 4?
No.
We can't, that's right, because when we add again, we must have radicals. Same index, same radical. These cannot add unless you had, for example, radical 2 here. Then you can add 3 and 4. But in this case, this one is a radical, this one is not. They're different. So just like adding 3x plus 4. When you add, for example, 3x plus 4, this doesn't add up. This expression stays like this. So same thing with radicals. So there's not much we can do here. We just leave that like that. Okay, so that's if you have a radical times a number and another radical. Let's see now what happens if you have two radicals. So if you have two radicals, maybe a radical 3. Or the radical 2. And maybe some other number here. Let's say 3. So again, we distribute. So radical 2. What is radical 2 times radical 2? Radical 2 times radical 2 is radical
6.
6 plus radical 9 times radical 9. I mean radical 3 times radical 3. That's radical 9.
Radical.
And this, can we simplify it a little more? So we can add these right away because these are different. So this basically is radical 6 plus radical 9, which is 3. You may try to simplify this. It would be radical 2 times radical 3. But it's not going to simplify. Even if you put radical 2, radical 3, which come from 6. This doesn't have a perfect root. This doesn't have a perfect root. So it won't help if you break the 6 down. Maybe if it was 8 or some other number, you could break it down. But with this one, this is not going to help. So we just basically, your answer is this, radical 6 plus 3. So be careful when you distribute. Again, do not make a mistake of multiply 2 and 3 here because this one does not have a radical. So you don't want to make a mistake here. Only multiply again if you have the same index. That's when you multiply the radicals. They both must have a radical. If one doesn't have a radical, then you can add, you can multiply or subtract. Let's see if we can do some more examples of multiplication here. Now we're going to see how to multiply 2. You may have 2 by 2. You may have 2 radicals, multiply 2 radicals. And we're going to see how to multiply and simplify them. So let's say you have radical 3 minus radical 5, radical 3 plus radical 5. Just like the distribution we saw before with binomials. So we're going to do the same thing. We're going to multiply all these, again, while being careful with the rules of multiplication. Start with the first one, radical 9, radical 3 times radical 3, that's radical 9. Okay, then radical 3 times radical 5, that's radical 15. Then negative times a positive, that's negative. Radical 5 times radical 5, that's radical 15. And the index is the same here, it's 2. All of them have index 2. And finally, this times this, that's a negative. 5 times 5, that's 25. All right, what do you think happens next?
It's a. I'm sorry. It's radical 3
First one,
square minus radical 5 square, right?
this is radical 3 times radical 3 is radical 9. What is radical 9 equal to? Square root of
9,
3.
3.
9. Right? And then what happens here? We have positive radical 15 minus radical 15. What happens to these?
0.
Right? These
You cancel them?
Yeah.
plus one thing minus the same thing. So these cancel each other out. And finally, minus
5.
25, which is 5.
5.
Is basically negative 2. So this whole thing, when multiplied, turns into negative 2, which is very convenient and simple, instead of having this long expression here. So you just distribute and simplify accordingly. Sometimes you may have some, let's say, negative 2 plus radical, let's say 8. And here you may have maybe 3 or radical 2 minus 3. You may have something like this mixed with numbers and radicals, but it's the same way, just multiply first and then simplify. So you gotta do, what is 2 times radical 2? Everybody, what is
Radical 4.
radical 2?
Cannot multiply, right?
Yeah, that's right. It's not a radical 4. This one does not have a radical.
That's right. Isn't it 2 radical 4?
2 radical 4, just 2 radical 2. Just like we did here, we have radical 2 times 3.
Oh, 2 radical 2.
Right, so radical 2 times 3, just bring the number to the front. Remember the whole number or the integer, bring it to the front of the radical. You can't times 2 and 3. This one does not have a radical, so we can't multiply them. Same thing here is 2 radical 2. Basically, just write them next to each other with an invisible multiplication. Then 2 times negative 3, that's negative 6. What is radical 8 times radical 2?
4.
2, right.
Will be
Radical 16.
4.
radical 16, which will be 4 later. Now, what is first positive times a negative is negative. What is radical 8 times 3?
3.
3 radical 8.
Exactly, 3 radical 8. Again, we don't times them because they don't have, this one doesn't have a radical. Now let's try to simplify if possible. So you have minus 6, this is 4, minus, can we simplify this radical? 3. We can turn the 8 into
2.
radical 4, radical 2. Well, we could have done it earlier here, but that's fine because this we can break down. So this turns into radical 2. Let's simplify these two. Negative 4, negative 6 plus 4, that's negative 2. Minus, we have 3 times 2. This is 2. Radical 4 is 2, so that's 6. Radical 2. What do you do next? Can we simplify more?
Yes.
You subtract the 2 radical 2 with the 6 radical 2.
Right, these are similar. We can combine them.
Can y'all move away? Because I have to talk here. I don't need noise. No, you just said you had mad bread. That's it.
So this will be 2 take away 6, which is negative 4. and this radical stays the same, and minus this 2. Can we subtract anything now? Can we subtract these 2?
No.
That's right, they're not the same. This one has a radical, this one does not. Again, to add or subtract, we must have the same index and the same radical. So this is pretty much the answer here. There's not much to be done. And you just leave it like that. So that's basically the how you multiply radicals. Let's see if we can do the division as well. Maybe we could. Yeah, let's do division as well. We're here, I'm going to add it. Okay, so we're going to do the division also, which is, a lot of it has this stuff. So let's do that. So number 3. So we're going to do division. The same rule applies here. When you have division of radicals, you want to have, just like multiplication, you need to have the same index, but not necessarily the same radical. As an example, let's say you have, let's say radical, so you have 32 here, and maybe radical 2. And you just have to have the same index. Do we have the same index here? Is the index the same here?
Yes. Yes.
Right? The index is indivisible to square root. So if you have that, just like with the multiplication, once we have the same index, we can combine those together with a multiplication, and they're the same radical. We just times these 2. It's the same thing here. We're just going to divide these 2. So it will be just one radical. Going to put 32 over 2. And the index again is still the same. So we're going to combine them into 1, just like the way we combine these into 1 here, because they have the same index. Then here we multiply it 4 and 2 to get 8. Same thing here, we have a division, so we're going to divide. It's going to be 16, 32 by 2. And of course, this is equal to, what is that equal to?
4.
That's right, 4. Okay, so check the indexes before you divide radicals. You may also have, let's say, if we have different indexes, let's say we have 3 here. $125, for example, and maybe 5 here. So these have the same index, which is 3, so we can combine them into one radical. We're going to divide 125 by 5. And the index is 3. What's 125 by 5?
25.
What is it?
25.
25.
5.
And we don't know the cube of 25. We can't break down the 25 into, the numbers we know the cube of are 8, maybe 8 and 27, not 25. 27 has a perfect root. So basically here we can't do much. We can only divide this or split this into 5 and 5, but it's not going to help because 5 does not have a perfect cube. So that's basically it for that. So you just leave it like that. Let's see another case with what if you have, say, radical of 5, and you have maybe 8 here. Can we divide and simplify these? Can we divide these two right away? The index is not the same. You cannot do this. Okay, so you cannot do 8 by 2. The index is not the same. We have 3, we have 5. But you can try to simplify this. Just like we did earlier, try to break down this, but it's not going to help because if you're looking for a number that multiplies 5 times to 8, that's going to be a decimal. Same thing here. This one is a decimal. So basically, this would stay like this. Okay, unless you want to get decimals, then you can plug this in the calculator. So can't divide. But we're going to see in a little bit how to at least remove this. We're going to see how to at least remove the radical from the denominator. Okay, so can't divide, can't simplify. So basically it stays like that. What if you have, say, negative 27? Can we divide these radicals right away?
No.
That's right, because the index is not the same. We have 3, we have 2. But doesn't mean we can't simplify at all. Let's see if we can simplify this, and maybe simplify at the end. Okay, what is the cube of negative 27?
-3.
Exactly, so the number that multiplies by itself 3 times to negative 27 is negative 3. And of course, the radical of 9 index 3.
3.
This will be
-1.
-1.
so kind of the same idea, okay? See if you can multiply or divide right away. If not, try to simplify. If not, that stays like that unless you really need a specific value. So you can use the computer or the phone to get your decimal here for this one. So that's pretty much how the division of radicals works. But there is another thing regarding division of fractions or division of radicals, which we can something called rationalizing. So when we can't simplify or divide, but we don't want the radical to be in the denominator. So we have a way to actually get rid of this radical from the denominator. So that's what we call rationalizing. We rationalize fractions or radicals. Okay, this is how this works. So if you have, for example, 2, and you have 3 here. So first, again, try to simplify and divide. Obviously, we can't divide these because this doesn't have a radical. This one has a radical. There's not much to simplify here. It's already simplified. This is simplified. So we'll do what we call rationalize. So rationalize just means get rid of this radical from here. Okay, so rationalize a fraction, it means we don't want the radical or the radicals in the denominator. And it's very simple to do. What do? You just take your fraction. And to remove this radical, you're just going to times it by itself. Why? Because radical 3 times radical 3 is basically radical 9, which is
3.
Okay, so when you multiply a radical by itself, when the index is 2, basically you just, that radical goes away. So radical 3 times radical 3 is 9, turns into 3. So again, to rationalize a fraction, just times the denominator by itself. If it's by itself, if we have, I'm sorry, I need to make 3. And as always, when you times the bottom of a fraction by a number, what do you do at the top?
Multiply.
It's the same.
Yes.
That's right. Because this fraction and this are the same. These are equivalent. Okay, so what we call equivalent fractions. So when you times the bottom and the top by the same thing, you get it's the same ratio. So then you times these. What is 2 times radical 3 again? 2 times radical 3 is 2 radical 3. What is the radical 3 times radical 3? As we said here, it would be radical 9, which is 3. Okay, so now that's good. That's good enough for us. We just rationalized it. We no longer have a radical here, which is good. That's all that we wanted to do. So when you say rationalize something, it means we don't want the radical to be in the denominator. As you can see here, so that's the answer. Even though it's still as a fraction, but that's exactly what rationalize mean. It means we don't want the radical in the denominator, and that's good enough. Okay, so again, just times the fraction by itself, and the radical will go away. Here's another example. Let's say you have radical 5. So what do you do to rationalize this again? You're going to times it by what? To rationalize this, we times the fraction by top and bottom by what exactly? We need to get rid of radical 5, so we're going to times it by?
Radical 5.
Right, times it by itself. And the top also by the same thing. And then negative 3 times radical 5 is basically negative 3 radical 5. And the bottom here is radical 25, which is basically just 5 here. And that's it. That's exactly what we needed to do. Rationalize. So as long as you don't have a radical here, that's fine. That's fine. That's basically what we wanted to do. You can't cancel the 5 and the 5 here because this is a radical 5. This is just 5. They're not the same thing. You can't cancel it. That's basically your how you rationalize when you have just one. We have one radical in the denominator. Okay, so we just times that by itself to get rid of the radical. Now we will see. We'll actually see how to do the same thing, but if you have more than one just radical, maybe 2 radicals, maybe a radical on the number. So let's do that over here. So sometimes we may have, let's say a radical 5 plus 3, and maybe some radical here, let's say probably radical, I'm actually use radical 8 here instead. Okay, so we want to rationalize this fraction or divide it. As always, if you want to divide, try to see if you can divide right away. If not, try to simplify. But here, you can't divide right away. This one has radical, but this one does not. So we're gonna have to do something else. Also, try to simplify if possible. So now, let's, again, the keyword is rationalize. So rationalize means we don't want any radicals in the denominator. Here, so if you have one radical, you just times it by itself. Now, if you have a radical in the number, it's a bit different from what we saw previously. So you write your fraction again. So here's what you do. To get rid of the radical from here, you take this and you times it by itself, but with a little change. So instead of the plus, we're going to use a minus. Okay, so you times the denominator by itself. But again, we change that plus into a minus. Or if it's a minus, you change it into a plus. Of course, do the same thing at the top. Same over here, radical 8. Okay, so if it's by itself, that's easier, just times it by itself. But if you have plus something else or minus something else, so you gotta take that denominator, times it by, we call this the conjugate of this, when you take the same thing basically, but you switch the sign that's in the middle. The rest is just multiplication. The rest is basically just like we did here earlier when we multiplied radicals. Okay, we did this, so that's basically what this is. So the top and the bottom. So it's going to be something like this, radical 2. Okay, so we're going to multiply these two. Also going to multiply these parentheses. We're going to distribute them exactly like we did above. All right, what's radical 2 times radical 2? Radical 8. Radical 2 times radical 8 is?
16, then 4.
That's right, radical 16, and here, radical 2 times negative 3 would be negative.
3, radical 2.
Exactly. Because again, this one doesn't have a radical, that's why we didn't multiply 2 and 3. Now at the bottom, we have radical 8 times radical 8. That's radical 64. Radical 8 times negative 3, so it's negative 3.
Professor,
Yes?
I have a question.
Mm-hmm.
This is a plus b multiply a minus b, so can we?
If you want to do the formula right away, that's fine, okay?
Okay.
But since we're doing a multiplication, we'd rather do it the traditional way, like this.
Okay.
But you can use the formula. So radical 8, 64, radical 8, 3 is here. Now we have another multiplication, positive times positive 3 radical 8, positive 3 radical 8. Finally, positive 3 times negative 3, which is negative 9. No radicals, because these don't have radicals. Now we want to simplify this, so radical, of course, 16 is 4, minus 3 radical 2. And here we're going to simplify as much as possible. First, we're going to start with radical 64, that's 8. Then what happens to these? Everybody?
Cancel it.
That's right, these are opposites. So these will always cancel out. The middle ones, when you rationalize a denominator like this, the middle ones will always cancel out because you will have opposite signs. So those are gone. That's what makes the radical go away. So that's the reason why we switch these signs, positive to a negative or negative to positive. So these two can be opposite. If you don't switch the sign, if you use the same sign here, these will not cancel out. It will be added. For example, 3 and 3 will be 6 here, and the radical will not cancel out. Remember, rationalizing means getting rid of the radical from the denominator. So that turns into 8. The middle ones will cancel out. And we have negative 9. As you can see, because these always going to be perfect squares, because we times a number by itself will be always perfect squares. And the middle ones will cancel out, so we end up over here with 4. And again, you can't subtract 4 and 3. This one has a radical. This 4 does not have a radical too, so it stays like that. Over negative 1. That's pretty much it. We can move the negative up. To get rid of this fraction, we can say, just move the negative basically up, multiply both of these by this negative. So it'll be negative 4 this turns into a plus 3 radical 2. So as long as you end up with a number or an expression without a fraction, or with a fraction but without a radical, that's all we needed. So we didn't want the radical in the denominator, and we got rid of it. It's no longer there. We have, you can think of this as 1, as long as you don't have a radical here in the denominator. That means we rationalized it, and that's pretty much it. So that involves a little bit of multiplication to rationalize denominators. Again, the keyword is rationalize. When you see that, it just means get rid of the radical from the denominator, not from here. We don't care about the denominator if it's here. We just don't want it in the bottom of the fraction. And does that make sense, everybody? Any questions at this point?
No.
Everyone, you guys okay? Want to hear from all?
Yeah. Yeah, no
No,
question.
thank you for explaining.
Okay, please let me know if something's not clear. Let's do one more example of rationalizing. So this time was 1 radical here. Then we used 1 radical in the number. Now let's use 2 radicals in the denominator and see how to rationalize it. So let's say radical the radical 5. Let's make it a little more complex. So let's say radical 5 minus radical 2. Or maybe just randomly put 7 here. So that's a fraction again. We want to rationalize it. That means we want to get rid of these 2 radicals in the denominator. Not this one, but these 2, we don't want them here. So what do we multiply this fraction by in order to get rid of these 2 radicals? What do we multiply this by? Again, kind of like this, very similar. You want to get rid of these 2 radicals. So we're going to times this by what?
By radical 5 plus radical 7?
That's right. So we're going to times it by itself, except we change this to a plus. So let's write the fraction again. So radical 5 minus radical 7. And again, to rationalize something, just times it by itself. And we switch the sign in this case. This minus turns into a plus. The exact same thing at the top, radical 5 and radical 7. Not from here, but from here. That's it. The rest is just multiplications. Again, we're going to repeat the same process. The same thing as we did here. We multiply 2 radicals by 2 radicals. So we did this as well. So basically we have one of these and one of these here. So multiply carefully and try to simplify. So let's start with this. So we're going to need parentheses here. We have 2 here. We have 2 numbers here. So radical 10. Then radical 14, positive. Then negative 3, radical 5. And here we have negative 3 and radical 7. Let's distribute the bottom as well. So radical 5 times radical 5, that's radical 25. And radical 5 times radical 7, that's positive radical 35. Then negative times a positive will be a negative. Also 35, 7 times 5. Finally, negative times a positive, it's negative. 7 times 7, that'll be 49, radical 49. Okay, so let's simplify now. Radical 10, basically, it's just radical 10. Even if you break it down into 2 and 5, it's not going to help. 14 is just 7 and 2. None of them will be a perfect radical, so it's not going to help. This is already simplified. This is already simplified. So there is nothing you can do here. So we have a bunch of radicals. You all have different radicands. 10, 14, 5, 7. Even though the index is the same, it's 2 all over, but the radicands are not the same. Just like we saw earlier here, when you add, you must have the same index and the same radicand. If not, you try to simplify the radicals first. Here, nothing can be simplified or broken down. Like I said, 5 and 2 will not help. Neither 5 or 2 has a perfect radical. Same thing with 14. These are already simplified. You can't subtract these two because the index is not the same. I mean the radicand, even though the index here too is the same. So that stays the same. Okay, so nothing changed at the top, and that's fine. That's perfectly fine. Don't worry about it. Here we can turn this into 5. What happens again here in this denominator?
The radical 35 plus and minus cancels out.
Exactly, these two cancel out. That's the reason, again, we switch the signs. So we can have these two radicals cancel out. These will always be turned into whole numbers because with times a radical by itself, it turns into a whole number. So that's gone, minus. This turns into?
7.
That's right, just 7. Finally, again, this is still the same. And over here, of course, this is -2. And that's pretty much all. There's nothing else we can do here. This stays the same, it doesn't simplify. As long as we don't have a radical here, that's the purpose of this question. So this is rationalize. Rationalize means get rid of the radicals from the denominator. And that's exactly what we did here. And that's your final answer. So this, all this here over -2. As long as you don't have a radical, that's good. We rationalized the fraction. So it's basically how you do all your operations with radicals. Again, refer back to the previous lecture. We talked in detail about the index, the radicands, and simplifying radicals. So we have a whole lecture on introduction of radicals. And in this class, in this lecture, as you can see, we learn how all the different operations of radicals. Okay, we're gonna need these later when we do quadratic equations and other things. And rational equations or radical equations, we're gonna be using this. So next class, it's gonna be about radical equations.